Until a few years ago, users used our applications from a PC. But today's users demand to be able to perform their tasks with the device they have at hand. At the office, they'll still use a PC, but while walking or on the commute to work, they'll use smaller devices such as cell phones or tablets, or even smartwatches. When they're at home, they can even use a smart TV. All of these devices will provide the ability to reach users in a way that was previously impossible. According to publications, it's estimated that users spend more than 5 hours using their mobile devices, and more than 53% of global internet traffic is currently generated from these devices. However, why do we need an application for smart devices if we already have a web app that users can access from their devices because it's also responsive? In this video, we'll try to answer that question. Also, we'll see the most important features of the apps we can develop with GeneXus. And at the end, we'll see an application and how it was developed. First, let's see responsive web applications. The advantages of this type of application is that they're available for all users, they're easy to maintain, especially with GeneXus, and they have lower development costs. On the other hand, their disadvantages are as follows. They can only work online, they always need an internet connection. The navigation method isn't natural. It isn't native to the device because the browser navigation is used. They also won't provide access to certain device features, such as the camera and GPS. And lastly, it can be said that they generate less user engagement with the app because it's not an app installed on the device. Now, about native apps for smart devices. The advantages are that a connection is not always required. We can have offline applications, partially connected or totally disconnected. We can use hardware features such as camera, GPS, fingerprint reader, and everything else in a natural way. They'll offer a better user experience. In addition, since these applications must be installed on the device, they generate greater user engagement. On the downside, we need to develop for multiple platforms, Android and iOS. This is something that's solved by GeneXus. They have higher update and maintenance costs, and, as we've mentioned, they must be installed. This diagram shows the architecture of online apps developed with GeneXus. On the one hand, we'll have a native language application that will be installed on devices, either Android or iOS, and they'll be the clients in this architecture. On the web server side, there will be a layer of web services that use the REST protocol. These services or APIs that the clients will use are made up by data providers, processes, and business components, which implement the entire data access required by the application. Because it's an online application, when there's no connection, we won't be able to use the application because it won't be possible to access the server to execute the REST services that provide the data to the application. On the other hand, in offline applications, on the client side, in addition to the application, we'll have an SQLite database with all the tables that the application needs. The entire data access logic will be in the application itself, and all the operations performed on them will be done in the client on this local database. In the web server, we'll have access to the centralized database. And in the REST services layer, we'll have the necessary synchronization services to provide the client with the updated data whenever it requires them. In addition, there will be business components that will be used for the client to inform us of the changes made locally. In this scheme, when there's no connection, the application can continue working normally, but it won't have the latest version of the data. This will be automatically synchronized when the application detects that the connection was reestablished. GeneXus allows developing applications for smart devices almost in the same way we develop web applications. To this end, we have specific objects for smart devices, which we'll see in detail shortly. We'll also see other features such as semantic domains, integration via APIs with the device hardware, the possibility of generating connected or disconnected applications, security through GAM, use of stencils, and a wide range of specific controls for smart devices. Let's now see the specific objects for the development of applications for smart devices. The Menu for Smart Devices objects allow us to define menus for the applications, which can be displayed in different ways, such as tabs, a table, or a list. To the right, we can see the structure of the object, where we can define the items that this menu will have. Each item has a name and a description, and we can associate an icon that is an image from the knowledge base, and an object of image type. Then, in the events, it's then determined what happens when we access each specific item, or what object will be called. Normally, these objects will be the entry points to the application, so by default, they'll be main objects. We'll see the menu at runtime. In this case, we use the tabs control type, as you can see at the bottom. The panel for smart devices objects are similar to the web panels we use in web development. They have an abstract layout in which we'll insert the necessary controls such as tables, text blocks, grids, images, and so on. This panel we see here was built with this layout in a panel for smart devices object. Its main features are as follows. Its layout is completely flexible. When creating an object of this type, its implementation will be left to the developer. In this way, we can use it to show information to the user, or for the user to enter information, or even a combination of both options at the same time. We can create complex screens, for example, to create an assistant with several steps. We may use it to create a menu, as it can also be a main object and therefore an entry point for our application. We can use it as a reusable component, similar to the way we use web components. And we can use it to show information returned by data providers for REST services. In addition, we can implement multiple grids, and many other uses in addition to those mentioned here. Our apps for smart devices will be multi-platform. This means that we create basically the same app and do the minimum work required to customize it so that it runs on Android and iOS devices. All this while still following their design and behavior guidelines. To customize the look and feel in each knowledge base, there will be two themes already created. The first is Carmine iOS and the second is Carmine Android. And by default, these themes are associated with the Android and iOS platforms. The WorkWith for Smart Devices pattern is a type of object specifically used for smart device application development. It implements all the features required to manage the data of an entity, including accessing a list, accessing an item of that list to see its detail, adding new records and editing them. Also, it's capable of generating additional screens and links, analyzing related data such as sublevels, foreign keys, and relationships with other subordinated tables. Next, we'll see a demo and use this pattern so you can see how it simplifies development tasks. To take advantage of the integration with the device hardware, we have semantic domains. For example, the address domain is used to store addresses at runtime. Tapping on it takes you to the default map application installed on the device and locates that address. The email domain is similar, but is used to store email addresses. Also, tapping on it will open the default application to send email messages. The phone domain is used to store phone numbers, and tapping on it will open the default phone call application. The image domain is used to store images. In edit mode, the user will be asked if he or she wants to take a photo with the device's camera, or if he wants to select an image from the gallery. The URL domain is used to represent web addresses. Just like the previous ones, tapping on them will open the default browser. The audio domain allows you to manage content in audio files or allows you to record an audio using the device's microphone. The video domain is similar to image, but for video files. We can record a video with the camera or select one from the gallery. We can also integrate through APIs. Let's see some of the most used ones. Interop. This API offers an entire series of methods to interact with common functions like send message or send a text message. Play video or play audio to play multimedia files. Place call to make a call. Send email to send an email message, or message to show a message to the user. Or confirm to ask the user for confirmation before executing an action. The Calendar API allows generating an event in the device's default calendar application. The Contacts API, it allows us to interact with the contacts application of the device. We can add contacts, delete them, see the information of a contact, or get the entire list. The Scanner API allows us to use the camera of the device to scan barcodes or QR codes. Also, it has methods to scan a single code. In that case, it returns the value in a variable of char type or in a loop, and at the end returns a list of all the codes scanned in a collection based on the SDT scanned barcodes. The SD Actions API provides standard methods to call the login and logout from the app, go to Home, which returns to the initial object, Return to allows you to return to a specific object. We also have the Maps API. This can be used in web and smart devices apps. It allows you to calculate paths and get the routes between 2 points. There are many more APIs to use. You can find more information on the wiki or in the course on developing mobile applications with GeneXus. Let's open GeneXus to see some of the things we've been talking about. In this knowledge base, we've already developed part of an application for the travel agency we've been working with. First, let's see the use of the WorkWith for smart devices pattern. In the attraction transaction, I've already applied this pattern. I'll show you how I did it. In the Patterns tab, we need to go to WorkWith for smart devices and select this checkbox. There are several differences regarding the pattern for the web. The first thing you'll notice, and the most obvious one, is that when applying the pattern, objects that depend on it are not generated. The pattern instance is an independent object that, when applied to a transaction, is associated with it, but the objects generated by the pattern are not independent objects. When applying the pattern, some transaction properties will be modified. For example, the business component property is set to true. Also, it's configured to be exposed as a web service and REST protocol. The pattern will generate a list node for the main level of the transaction. It's similar to the WorkWith web screen. It allows listing all the records. Filters are automatically included. New records can be added, and the existing ones can be queried. To see a record, we open its detail, the Detail node, and the sections we see here. The sections are generated automatically. A general one that will contain information of the record that we're seeing, and an additional section for each table with which we have a one-to-n relation. Here, for example, info is the second level of the transaction. Then, here we'll see a list of all the records. Now we see trip, which is a table with a trip attraction sublevel. It contains the relation between trips and attractions. Each one of these nodes is an object. For example, let's go to the list. Here we see the layout directly. This is another difference from the web pattern. The other difference is that here we can modify it freely, either its layout, rules, events, and so on. The detail node we see here is a special object. It will be called when we select a record from the list. We can see that it receives the primary key as parameter. What this node does is display the general sections and others that exist. Each one of the sections also receives as parameter the primary key to be able to show only the information related to the record we chose. In the general section, the information is tabular. In the others, it's a list, as they're one-to-n relations. Also, in the general section, we'll see the actions programmed to update and delete the record. And this object in particular will implement two layouts. One, when called to view, which is the one we're seeing, and the other one, which is the editing layout that implements the save and cancel actions that we see in the events. Note that in each smart device object, we can add additional layouts. When adding a new layout, this dialog is opened. It indicates the configuration in which the layout will be shown. We have the platform to which it applies, the type of device, the mode, the size, and so on. The application we developed has a menu created with the Menu for Smart Devices object. Let's open the Travel Agency object. Here we can see the options implemented by the menu. In this case, there are three options: SD Home, SD Attractions, and SD Contact. For each action in the events, the call to the object we want to show is defined. Menu for Smart Devices objects are configured as main by default. And in them, we can set the properties the application will have. The title, in this case, Travel Agency. The default orientation, and if we enable push notifications, for example. If it's an offline application, we can indicate the associated offline database object. And, for example, for Android, we have properties to indicate the application icon, the notifications icon in the status bar, and push notifications. We can indicate, for example, if we use Maps or some other Google API, the Android Google Services API key. There's another group of specific properties for Apple, another group for notifications, another for security for Facebook, Twitter, and so on. When we create the first object for smart devices, a smart device generator will be automatically created in the generators. Here, we'll indicate some properties, for example, if we want the application to be generated for Android and for iOS and the main platform. One very important property is the URL to publish the REST services to which the application must access. This URL must be accessible from the device that we use, either physical or the emulator. This is one of the advantages of deploying in the cloud, since this URL will be a public address. If you use the full version of GeneXus and can use local deployment, then you must try to have the device in the same network as the web server. The configuration of platforms as SD platforms will also be added in customizations. Here you'll be able to, for example, associate a specific theme with each one. The navigation style can be flip, split, slide, or cascade for iOS. Note that not all styles are valid on all platforms. For example, in Android phone, slide and flip, which is the default, but for an Android tablet, split is added. Meanwhile, in an iPad, cascade is added. And this is where you'll establish the relationship between the platform and the theme that will be used. In addition to Carmine SD, which is a theme for smart devices, we have Carmine iOS and Carmine Android. Here, we created Travel Agency Android using Save As of Carmine Android, and a similar one for iOS. A copy of Carmine iOS. For example, let's see the Carmine SD theme. Here are specific classes for development for smart devices, such as the application or application bars classes. So for example, we can set the application colors. In the platforms, for any Android, the theme Travel Agency Android is being used. And for any iOS, Travel Agency iOS is used. Now let's see an object of the panel for smart devices type. We open SD Attractions. In the layout, there's a grid, and inside it, there's a table with the attraction image, and the name and ID which is hidden. This is shown in this way because the stencil, attraction in list, is being used. Take a look at the stencil. It's used similarly as in web apps, but here the SD layout is taken into account. Note that here is a canvas, which contains the image and name. The ID is hidden, as we've said. Going back to the SD Attractions panel, note that a grid is being used. But there's a horizontal grid control of SD type. This shows 3 rows per page and a column. In the grid search, we enter the attributes used to make the search for records. In this case, by name and description. Another thing we've customized is the grid's default action. Here we indicated that a detail event must be executed. It's a user event, and we can see that here the detail screen provided by the attraction WorkWith is being called. So we run the application. And to do so, we can right-click and select Run on the travel agency object that is set as the main object. Also, you can set it as a startup object and click on Run or press F5. Now the application will be generated and compiled at the end. The emulator will be opened, and the application will be installed, opening the initial panel. In addition, when there are objects for smart devices in the developer menu, there will be QR codes that will allow us to install the application on physical devices by scanning this code. Obviously, the device must be able to access the web server. To see it, we can run it by accessing through View and the option Show QR Codes. Note that the developer menu is opened and shows the QR codes, one to install on Android and another for iOS, if this platform has been set to true. Also, there's a link to download, for iOS, an application called Knowledge Base Navigator that allows running the interpreted app on an iPhone or iPad. In this way, we don't need a Mac to compile it, because metadata is generated for the KBN app installed on the device to interpret it. In this way, you can prototype on iOS without a Mac. To prototype on Android using a physical device and to install the app, you can use the QR codes for Android. Or, simply connect the device to the development PC where GeneXus is run. The drivers must be installed, and the device must have installation from unknown sources enabled. There, GeneXus will detect the device, and instead of opening the emulator, it'll install the APK on the device. Let's see the application. The three options are displayed as tabs: Home, Attractions, and Contact. We select Attraction, and here we can see the grid that uses the horizontal grid SD control that we've mentioned before. We can access the detail of an attraction from the detail node provided by the WorkWith pattern. This contains the related information. The grid, as we've said before, allows viewing pages from 3 records. We open the contact panel, which has, for example, a contact form, that after confirmation calls a process that adds the record using a business component. These icons allow interacting with other applications installed on the device. So for example, you can create a tweet, and you're asked if you want to send a direct message or a tweet. Also, you can watch a YouTube video. This opens another panel showing the video. Here, integration with Semantic Domains is used. And, for example, on Facebook, a certain page is opened. And for Instagram or LinkedIn, they're similar. All this is achieved using APIs, interop in some cases, and the Twitter API in other cases. Similarly to when we develop web apps, for smart device apps we can also use live editing. To do so, the application has to be run again in live editing mode. So let's run it. When using live editing, you can make changes to the layout or to events running on the client. They must not be start, refresh, or load events, those running on the server, or changes that don't imply new navigation or retrieving an attribute that didn't exist before, because in those cases, the REST API providing this data must be recompiled. Here it connected to live editing. So we refresh the Live Inspector screen. We can zoom in and move the panel, just like for a web app. Every time we move in the emulator, as in this case, or in the physical device, we'll see the changes in the live inspector. Now we can open the SD Attractions object and add a button in the application bar that allows calling the WorkWith attraction list. We'll add a button labeled Backend and set the properties to low priority to display it as an icon with 3 items that will be displayed in the application bar. And the event is defined. Let's see it first in the emulator. We can already see the button, even though it doesn't do anything. We program the event, call WorkWithDevicesAttraction.attraction.list, parentheses, and we can see this change automatically in the device, without having to generate the application again. If we open the list, here we see an icon with another symbol to insert. Let's go back. Or, if we access a record, we'll see the options, the icons to edit or delete it, and in the detail, we see the general section that is the first tab, in addition to info and trip, the other 2 sections that we saw before. So, for example, we could also add a text block in the layout, and we'll also see it automatically using live editing. In the caption, we'll enter some title and go to the emulator, and there we see it directly. We'll change the title to Attractions, and for example, we can also change the class. We'll do this by selecting Section Subtitle. We enter section title that looks a little bigger, and now looks good. All this using Live Inspector will obviously make life much easier. And we can also edit the class directly. Not only to make modifications in the layout. For example, we'll use primary dark as color, and there we see that the change has been automatically made. In this case, we're modifying the theme class. And in the Live Inspector screen, we can also make changes. Not only in the object, we're going to set secondary text as 4-color, and we automatically see it both in the emulator and in the Live Inspector screen itself. Okay, now that we have the WorkWith component, we'll make a change using the device, in this case, the emulator. For example, we edit the Cologne Theater. We'll change its category, for example, from Cultural Place, and we'll change it to Tourist Site, and confirm. Well, it already indicates that the information was modified. And if we access the backend, WorkWith Attraction, which is the WorkWith web, we can see the change already made. Now we'll leave it as it was before. To do so, we change here through the web. the category of the Cologne Theater, and set it to 6, which was the one it had before. Cultural place, and we confirm. And there we can see that the change has been made on the device. But what happens if we don't have an internet connection? For example, let's turn on airplane mode to simulate that there's no internet access. So in this case, we'll see that some screens will work in the application. If we go to Home, for example, or Attraction, or if we enter the museum, the Louvre, we can see the data. This is because some of the ones I was already testing were saved in the cache. But, for example, if I access one I had never opened before, a message is shown saying that I don't have an internet connection. Let's go back. In the back end, we can see the list, because the data is already cached on the device. But if I enter any attraction that I haven't accessed before, it also gives me the message that we have no connection. To avoid this, we can use the applications offline. How's it done? In the main object, we'll simply change the connectivity support property and set it to offline. After this, we have to generate the application again. And then we can go to the main object and use rebuild. And with that, we'll convert our offline application. And it'll have all the necessary synchronization features automatically, and so on. So that's it. Now let's go back to the presentation. As you may have noticed, smart device application development is a very broad topic and covers many other issues that in this video and the demo we've seen in a simplified way, or that we may have just mentioned. I invite you to continue studying in greater depth all these topics and many more in the course on mobile application development with GeneXus from the training website.